Hello, geometry students, and welcome to part 2 of this lesson. One of the reasons I wanted to make sure we go through arc length and area of a sector, it's mostly calculator work, it's mostly formula work, but these are formulas that could show up on your ACT, and I think that they're pretty important to go over regarding circles. All right, so let's begin. The first term we want to talk about is circumference of a circle. This shouldn't be the first time you've seen it, but as a reminder, circumference is just a word that is special when we want to talk about the perimeter of a circle. So the circumference of circle is when we want to measure the distance in, say, inches or centimeters completely surrounding the circle. The formula for circumference is 2 pi r. When we want to talk about the area of a circle, the area of a circle is asking about, well, what if I wanted to carpet the circle? How many square centimeters, how many square inches, how many square feet would it take to cover the inside of that circle? The formula for area of a circle is pi r squared. I remember the difference between the two formulas by recalling that I have a power of 2 in the area, and we measure area in square units. So that gets the power of 2 because area is in square units. Versus in perimeter, the 2 is not a power, it's just part of the formula. So circumference and area, these talk about the total circle. When we talk about arc length and area of a sector, these are talking about parts of the circle. So what do we mean by that? Let's talk about arc length. All right, when we talk about arc length, okay, here is an arc. And in the previous video, we talked about how we could measure that in terms of degrees. But we can also measure this arc in terms of a length. How many centimeters, how many inches as a piece of the circumference. So we make a proportion. If you want to find arc length, you take the measurement of the central angle, that's a part, over 360 degrees, which is a total. Part over total. And that is going to equal your arc length, which is also a part, over the total length, which is 2 pi r, or the circumference of the circle. So central angle over 360 is equal to arc length over 2 pi r is going to be the proportion we will use to solve for arc length. Okay, we also have a formula for area of a sector. An area of a sector's formula is, you're going to take, again, part over whole. The central angle over 360. Think of that as a percentage, and you're going to multiply that by the area, which is pi r squared. So what does area of a sector and arc length mean? Well, if I was to talk about this piece or part of the circle, your arc length is talking about the distance in inches or centimeters or miles or whatever the problem is between A and B. Your area of a sector is talking about how many square units can I fit inside of that. So I'm going to make the analogy to a piece of pizza. In a piece of pizza, your arc length is the crust length, and the area of a sector is how much area is the whole piece that you're eating. I think I just spelled that wrong. There we go. All right, here we go. Let's do some examples. Let's find the arc length of AB, and I'm going to erase this out of my viewing area. Okay, when you want to find arc length, the first thing we need to figure out is what arc are they discussing. And we're discussing AB. AB has 2 letters, so it's the minor arc. So the central angle of that arc is 120 over 360. That's going to equal the arc length, I don't know, over 2 times pi times 4, which is my radius. Then I'm going to cross multiply. Remember, if I go too fast, you can pause, stop, and rewind this at any time. So I get 360x is equal to 2 times pi times 4 times 120. And in order to solve, friends, I just put this all in my calculator. So I'm going to do 2 times pi times 4 times 120 all over 360. 2 times pi times 4 times 120 all over 360. And that gives me 8.4. This is a linear measurement. This is not about what it is in terms of being a squares. So my answer would just be 8.4 miles. Let's now look at an area problem. Area of a sector problem. Okay, so in my area of a sector, what they're asking here is how many square units would fit inside that portion. So what do? We take the central angle, which is 135 over 360, and I'm going to multiply that by the area, which is pi r squared. Instead of r, my radius is 17, so it's pi times 17 squared. This is something you just use your calculator for. So I'm going to have 135 times pi times 17 to the second power all over 360. Oops, that didn't, let's try it again. So 135 times, that's probably going to be sloppy, 135 times pi times 17 to the second power all over 360. And this gives me 340.5. But remember that this is going to be in square units. Okay, let's practice some more. Let's suppose that the radius of this circle is 5 inches. Okay, so the radius is 5 inches. We want to find the circumference and area of the entire circle. So when I find the circumference and area of the entire circle, this is a total. So here we go. Circumference, its formula is 2 pi r. The radius of this circle is 5. So I want to discuss what can happen on an ACT. They can talk to you about the answer in terms of pi. If it's in terms of pi, I just take the whole numbers, I multiply them together, and so 10 pi could be a solution in your choices on an ACT. However, if you wanted to know what its decimal approximation is, 10 times pi would be 31.4. And this would be, since they gave it to us, I'm struggling here with the iPad, since they give it to us in inches, this would be 31.4 inches. Now let us compute the area of the circle. Area is pi r squared. So area is equal to pi times 5 squared. If you want the answer in terms of pi, it would be 25 pi. If you wanted it as an approximate decimal, 25 times pi gives me 78.5, but that would be in square units. Okay, so that's the answer to the top. Now they want us to find the arc length of BD and the area of its sector. So let's identify BD. B to D is a minor arc, so that means I'm going to go this way because it has to be less than 180. So this is the piece we're talking about. We have to first compute the central angle. We can compute the central angle by using angle addition. 66 plus 45 gives us 111. So the total central angle is 111 degrees. So if we want to find the arc length, I'm going to take 111 over 360 is equal to the arc length I don't know over 2 times pi times 5. Well, we already discussed that that's 31.4, so that's going to help me out, maybe with less keystrokes. So I solve by using cross products. So I get 360x is equal to 31.4 times 111. I'll use parentheses. I think that might be easier. And I'm going to solve by dividing both by 360. So I'm going to take 31.4 times 111 all over 360, which yields an arc length of 9.7 inches. Now let's talk about the area of the sector. When I do the area of the sector, I'm going to take 111, my central angle, which is my part over total 360, times pi times 5 squared. Well, again, in the previous step, we determined that 78.5 was what pi times 5 squared was. So this is just going to help me with my typing. So 111 over 360 times 78.5 is going to give me the area of the sector. So I'm going to take 78.5 times 111 all over 360. Oops, I forgot a decimal place. 78.5 times 111 all over 360. And so that gives me 24.2. Remember, area is measured in square units, so this would be 24.2 inches squared. Okay, let's do some more practice. Okay, when I look at this next problem, they want you to find the area of the shaded region. All right, so when I look at the area of the shaded region, I'm going to need a strategy. My strategy is I'm going to look at the whole entire circle, and I'm going to find the area of the total circle. Next, I'm going to look at the area of just that inner circle. We're going to compute that. And in order to get my shaded region, I am going to subtract those two in order to get my shaded region. So let's find the area of the total circle. Formula is pi r squared. If I look at the total circle's radius is 4. So this is going to give me pi times 4 squared, which would give me 16 pi in terms of pi. I'll convert that to a decimal at the end. Then I want to subtract off the area of the inner circle. So the inner circle still has a formula of pi r squared, but the radius of that circle is 2. So this is going to give me pi times 2 squared, or 4 pi. So when I subtract 16 pi minus 4 pi, I would get 12 pi inches squared if I left my answer in terms of pi. Or if you prefer a decimal, 12 times pi gives me 37.7 square inches. And that would be the area of the shaded region. All right, in this question, this is a pretty straightforward question. You should be able to identify that what the question is asking is just for the area of a sector. Why? Because it's a piece of pizza and they want to know what its area is. So again, we're dealing with area, not arc length. So I'm going to take 65, which is the part, over the total, times pi, and my radius is 4 squared. So I just pop that in my calculator. 65 times pi times 4 squared all over 360, and we get 9.1, and again we measure in square units. If I go too fast at any point, reminder, you can stop, pause, and rewind. All right, so when I look here, I do have a misprint, nothing is shaded. So this is going to be another, oh, that's not what I wanted. I wanted the highlighter. Let's do the highlighter in gray. All right, this is the problem that we're going to do. We're going to look at that area of a sector again. All right, so when I look at the area of the sector, I have 145, which is my central angle, over 360 times times the area of the circle, which is pi times 14.2 squared. We just pop that in. So 145 times pi times 14.2 squared all over 360 gives me 255.1 square units. All right, 2 more to do, friends. We're almost there. Okay, let's find the area of the shaded region. All right, here is my strategy on this problem. If you notice, this is 43, that means this has to be 43 degrees. What I also notice is, depending on how you look at it, if I look at it this way, angle 43 and then the angle marked in red are a linear pair. So if I take 180 minus 43, I end up with 137 degrees. So that means this is 137. So this is 137. Since we have congruent central angles, that means this sector and this sector are the same. So my strategy is I'm going to take 2 times the area of that sector, and that is going to equal the entire shaded region of the picture. So I'm going to take 2 times 137 over 360 times the area, which is pi, and I have it covered up here, but the radius is 6, times 6 squared. All right, so here we go. I'm just going to pop that in a calculator. So I have 2 times 137 times pi times 6 squared all over 360, and I get 86.1 square centimeters as my total shaded region. All right, friends, we're at the very last problem. Trying to pinch. Okay, here we go. Last problem. I like this problem a lot. Okay, got to use a little critical thinking here. Couple of things we noticed in the picture. 10 feet describes this diameter. That means each of these is 5. Okay, you need to remember that. The radius of the inner circle is 5. Here's what else I know. These congruent marks are pretty important. If the entire circumference of a circle is 2 pi r in terms of length, or in degrees 360 degrees, and you have divided them up into 4 congruent arcs, that means each of those central angles have to be 90 degrees. So that is what helps me start this problem. Even though they didn't draw it this way, I'm going to draw in those 2 lines, and I'm only going to focus on this piece of the picture. In doing so, I can divide this up into 2 sectors. I'm going to find the area of the entire sector. Then I'm going to find the area of the smaller sector. I'm going to subtract them. And when I subtract them, it will give me this area. And then I will have to multiply it by 2 in order to get the area of the shaded region. So that's my strategy. Let's execute it. All right, here we go. First thing I'm going to do is I'm going to find the area of the large sector. So remember that that's 90 degrees. So I have 90 over 360 times pi times r squared. And this is the key. This is the part that's tricky. Remember that the radii, all radii, plural of radius, they're each 5 in that small circle. So that means from this place to this place is 5. Then they have that this piece is marked as 2 feet. Using segment addition, that makes your radius 7. All right, so let's figure that out. I have 90 times pi times 7 squared all over 360. And that gives me 38.5 as the area of the large sector. Now let's find the area of the smaller sector. So what do I mean by that? We're finding just this piece. So again, it's still a 90-degree central angle, but now the radius is just only 5. So we're going to do 90 times pi times 5 squared all over 360, and that gives me 19.6. So what I'm going to do next is I'm going to subtract the 2. So when I take 38.5 minus 19.6, so when I take 38.5 minus 19.6, I get 18.9. But be careful, that 18.9 that we just calculated is only this area. In order to find the entire shaded region, we have to multiply that by 2. So I get a final answer of 37.8. And this would be square feet. All right, everyone. I hope you enjoyed today, and now you are prepared to do Unit 10, Lesson 2, Practice B. Both Practice A and B are due by Friday. Please visit me during office hours if you have any questions.